Alright guys, so today is Unit 5, Day 2, and we're starting with solving square root equations. So this kind of lays out, guys, step by step what I'm doing. So if you get lost or you forget the process, just go back and read these. But basically, I'm going to walk you through those right now. Okay, so step 1 says to isolate the square root, meaning this has to be by itself. Okay, and right now in part A, it is by itself. Okay, so now you're going to square both sides. So if I take this and square it, what I do to one side, I have to do the other. Now when you square a square root, it cancels out that. So remember, squaring cancels the square root. So that's going to be left with just an x. Okay, and that's equal to 49. You must check each equation. Okay, you have to, because sometimes answers get rejected. Okay, answers get rejected, which means there's no solution. So you must check it. So if you, this first one, I'll do a little check. I'm not always going to write them out, but you can also check them graphically. So you think the answer is 49. I'm sorry, yes, 49. So you substitute back in, and then you're saying, is the square root of 49 7? 7 equals 7, yes. So you do accept the answer is 49. Okay, part B. Be careful. That negative 3 is underneath. So you're still just going to square both sides. Squaring a square root just removes the square root. So on the left side, you're just left with x minus 3, and 5 squared is 25. To get it by itself, you're going to add 3 to both sides, and you get that x has to be 28. Again, a little check. The square root of 28 minus 3, you're checking to see if that's equal to 5. So it's the square root of 25, and you're going to get 5, so 5 is equal to 5. Yes, you accept that answer. Okay, next one here. Square both sides. I'm going to get 2x minus 1 is equal to 16. Add 1 to both sides, and I get 2x equals 17. Divide both sides by 2, and you're going to get x equals 17 halves. Okay, again, make sure you check. So you're going to get the square root of 2 times 17 halves minus 1, and you're checking to see if it's equal to 4. So 2 times 17 halves is just 17 minus 1, and again, still checking to see if it's equal to 4. You're going to get the square root of 16. You get 4 equals 4. You accept that answer. Okay, you're going to notice sometimes they don't check and then it gets rejected. All right, this one is the first hardest one, part D here. Okay, you're always going to move over the adding and subtracting first. So I'm going to add 4 to both sides. So I get 3 square root of x is equal to 24. Now I'm going to divide both sides by 3. So I get the square root of x is equal to 8. Now this part, now that the square root is isolated, so there's nothing else next to it, now it looks just like this question from part A. So now I could square both sides, and I get x has to equal 64. Okay, again, make sure you do the check. So 3 times the square root of 64 minus 4, and you're checking to see if that's equal to 20. So you're going to get 3 times 8 minus 4, checking to see if it's equal to 20. I get 24 minus 4, and I get 20 equals 20. It checks out, so I accept the 64. All right, part E. I minus 7 from both sides, and I get 2 times the square root of x plus 5 has to equal 6. Divide both sides by 2, and I get the square root of x plus 5 has to equal 3. I square both sides, and I get x plus 5 equals 9. Minus 5 from both sides, and I get x equals 4. My check. Okay, 2 times the square root of 4 plus 5 plus 7, checking to see if it equals to 13. So I get 2 times the square root of 9 plus 7, checking to see if it's 13. 2 times 3 plus 7 is it equal to 13? 6 plus 7 equals 13. 13 equals 13. It checks out. So I do accept this answer. Okay. All right. Last one here, part F. I add 4 to both sides. And I get 5 times the square root of 3x minus 2 is equal to 40. Divide both sides by 5. And I'm going to get that the square root of 3x minus 2 is equal to 8. Square both sides once that radical is isolated. And I'm going to get 3x minus 2 equals 64. Add 2 to both sides, and I get 3x equals 66. Divide both sides by 3, and I'm going to get x equals 22. Okay, the check. Don't forget, guys, for the check, you can also use the store key in your calculator, or and then it'll tell you true or false if you know you did it right. Okay, or that's probably the best way to check it using your calculator. So 5 times the square root of 3 times 22 minus 2 underneath the radical. Just taking up a lot of space there. Minus 4, checking to see if it's equal to 36. So I get 5 times the square root of 66 minus 2 minus 4, is it equal to 36? So 5 times the square root of 64 minus 4 equals 36. Okay, so this is a proper check, just kind of showing step by step. Okay, and then I end up with 40 minus 4, and I get 36 equals 36, so it checks out. So I accept the answer. You are going to see some examples here that get rejected, though. Okay, all right, which of the following is the solution? You could plug in all of your answers here, but remember, you want to isolate the square root. So how do I get rid of that 3? I divide both sides by 3. So I get the square root of x over 2 is equal to 5. Square both sides, and I get x over 2 equals 25. How do I get rid of dividing something by 2? I multiply both sides by 2, and I get x equals 50, which is choice 3 for example 7. Example 8. Consider the systems of equations. So a system of equations just simply means that you have more than one function, and usually you're trying to find where the two intersect. Okay, so you want to know where this is a square root graph, this is a line, it's linear, and you want to know where they intersect. Solve this system graphically for x using the grid to the right. Be sure to label your graphs and the intersection point. Okay, so remember, this is your parent square root graph, but it's just shifted 3 to the left. So if I shift 3 to the left, here's that one. And then from that point, it would be over 1, 2, 3, 4, up 2. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. Okay, so remember, that was 0, 0, that's 1, 1. That one was 4, 2. This one was 9, 3. Then the whole graph got shifted. So when I label that, that is y equals the square root of x plus 3. The next one is just linear. So that has a y-intercept of 1, and I move slope up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So I get this line right here, and that's y equals x plus 1. Okay? So now you can clearly see that my point of intersection, my intersection point is at 1, 2. So x is 1, y is 2. Solve this system algebraically for x. Check your answers in your original equation without using a calculator. Okay. So, anytime it's a system of equations, as long as they're both set equal to y, you just set these equal to each other, because it's like saying y is equal to x plus 1. So just set them equal. So I get x plus 1 equals the square root of x plus 3. Now we just learned how to solve this equation. This is all by itself, so now I'm going to square both sides. Be careful here though. This I actually have to FOIL. So it's going to be a little annoying, but just take your time. And remember, this just erases the square root. So on the right side, I just have an x plus 3. So this is going to be left with x squared. My outers is plus 1x, my inners is plus 1x, so that's plus 2x plus 1, and that's equal to x plus 3. Now you should be thinking that this is a quadratic or trinomial, so let's move these two over to this side to keep the x squared term positive. Okay, that's a big 0. So now I'm left with x squared. 2 minus 1 is 1, so plus 1 and then minus 2. I'm going to factor this. And then you're saying in your head, what multiplies to a negative 2 but adds to a positive 1, it's plus 2 minus 1. One step further, x is equal to negative 2, x is equal to positive 1. You must check into this original equation in order to see if you accept that. So remember, your equation was x plus 1 equals the square root of x plus 3. So now if I wanted to check x equals negative 2, you're going to substitute a negative 2 wherever you see an x. So I'm going to get negative 2 plus 1. Is that equal to the square root of negative 2 plus 3? So this, you're going to get negative 1 equals the square root of 1. Well, the square root of 1 is 1, and 1 is not equal to negative 1 is not equal to 1, so this answer gets rejected. Okay, that is not a solution, so that gets rejected. Okay, now I'm going to check when x equals positive 1. That's my other solution here. So I'm going to say 1 plus 1, is that equal to the square root of 1 plus 3? 1 plus 1 is 2, and then underneath the radical I now have 1 plus 3 is 4. The square root of 4 is 2. I get 2 equals 2. It checks out, so I accept the answer x equals 1. Now guys, that should make sense. Okay, this is where x equals 1. You substitute back in, you get y is 2. That's the only point of intersection. Okay, so part C says, what happened in part B? Does your work in part A verify this? And you're going to say yes. X equals negative 2 is not a solution. Okay, in part A, we found the only intersection was 1, 2. So the only answer was when x was 1, y was 2. Okay, you didn't have another intersection point there. Okay, something's really, really important here. Oftentimes, there's supposed to be a space there. Roots are introduced by various algebraic techniques that for one reason or another are not valid solutions to the other equations. These roots are known as extraneous and can always be found by checking within the original equation. If none of your solutions work, then you must write that there are no solutions, guys. Sometimes they both get rejected. Okay, this is called the empty set. So when you use the set curly brackets, and then this is called null. N-U-L-L, that looks N-U-L-L. Use one or the other, or just write no solutions. Last one here. Algebraically find the solution set of each of the following equations. Be sure to check your answers. I might get cut off a little bit here, guys, on time. But let's try it. It's our last example here. So I'm going to square both sides. And I'm going to get 2x minus 3 is equal to, and I'm just going to write this out so you can see it a little bit better. So I get 2x minus 3 is equal to x squared minus 6x plus 9. So you should be thinking it's a quadratic again, and move everything over to one side. And what I'm going to do, guys, I'm going to stop right here because I have to continue on another video.